Okay, welcome to another calculus video. We'll be doing a video on partial fractions. Partial fractions are just sort of an algebra technique. They're not usually taught too often in algebra though, but we do teach them a lot in calculus just because it is very useful when trying to tackle fraction integrals that just don't work any other way. So how do we know when to use it? Well, we're going to have a fraction, first of all. It looks similar to this. So what's going to happen is the big key thing is if we can't use u substitution. What does that mean? Well, if we try to use u substitution, we'll have a du that's 2x minus 5. That doesn't work, right? Because we can't cancel 2x minus 5 with anything in our expression, which means we can't use u substitution, which makes it feel like this thing's impossible. Of course it isn't, but we have to use a very specific technique. So what it is, partial fractions relies on first your fraction or your little expression polynomial on the bottom to be factorable. So if you can factor this, then we're pretty good. So let's see if it's factorable, and if it is, we'll try to use it. Okay, so that would be negative 6x squared, because we multiply these two things, and then we have the bottom one, or the middle one, be on the bottom here. We want to find two terms that would sort of multiply to give us negative 6x squared and add to give us negative 5x, right? So that's going to be, in this case, it would be something like 6x and 1x. That would kind of work because if we made this a negative, well, negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So that's good. We found the combination. Also, if you're kind of rusty on factoring, I have a video on it. Feel free to watch it. But we factor the thing, right? So all we do is when we factor an expression is we go ahead and we put that as two kind of factor pairs being multiplied. So this would be x minus, we would have a 6 here because we said it was a negative 6, so we have a minus 6. And we have an x, and it's going to be plus a 1 because we said it was a positive 1. Okay? All right. What do we do now? Well, we have to do a very special trick, okay? So the partial fraction part, this is what it is. So we have to make a statement, okay? We're going to have to say that we have an original thing we just kind of separated from the polynomial, and we're going to say this is equivalent to breaking up this fraction into two different fractions with a single thing, some thing on top that would make it work. So some number. So let's call one of the numbers a, and we would say x minus 6, plus another number b, x plus 1. So all we're saying is that just like when we add two fractions together and they're going to give us this fraction here, that's what we normally would do, we're just going the reverse. We're saying we have this total fraction here, there must be two fractions that we can add together, we separate it, that would give us this original fraction. So we're saying that some number here, we add the two fractions together, we get the original fractions. That's the idea. Just know that when they're nice, normal partial fraction problems where every kind of term is a linear one, that means that their x is just the power of 1 here, we can just assume that the number on top is just a number, an a or a b. And I will show quirks in other videos that when it's not that case, we have to do something a little harder, but just know this is how most problems go. Okay, so now we've accepted that, we make that little statement, we're just saying that, and now what we want to do is we want to make this thing kind of remove the fractions. We're going to do the same thing, we're going to show that same statement, we're just going to remove the fractions because, you know, it's hard to work in fractions, everyone agrees on that. So we have x plus 6, we have x plus 1, and we're just going to multiply, just like we would of normal equations, we're going to multiply everything by that so we can get rid of the fraction on each bottom. Okay, so how that works is if we multiply this, the bottom, so again, whenever we multiply after this step, we always choose the number that is the same, or the terms that are the same as our big original fractions. So we have these two terms here, so we multiply everything by these two terms here. That's all we're doing. Okay, so we have this term here, this term here. Of course, they're the same thing, so they're going to cancel. That's good. So we just have a 1 now. Now we're going to multiply this whole thing by each term, because remember, if we multiply the same thing by everything, then the expression is still the same. Okay, so if we multiply this whole thing by this one part here, or x minus 6, should be a minus, I'm very sorry, this would be a minus. The x minus 6 will cancel, right, because they're the same. but the x plus 1 won't, right? So the x plus 1 would be multiplied here, and then we would get a times the x plus 1. That makes sense. Okay, and then something very similar happens here. We multiply the whole thing. Okay, the x plus 1 cancels. That makes sense. And the x plus 6, the x minus 6, I'm going to keep doing that, I guess. The x minus 6 is left. Okay, so now that we have this as our new expression, remember, it's the same expression. We just multiplied the whole thing by the same thing, by this term here. That's all we did. Okay, so it's the same thing. Now what do? Well, we have to pick values, special values, that will help us isolate an A and a B separately. How do we do that? Well, we want to look at every linear pair you see, and you always want to pick the value that will kind of get rid of one, or they'll go to 0. How does that look like? Well, we have x plus 1, right? So if I had x plus 1, what would I plug in x here to give me a 0 so that the A will be canceled, and I just have the B to worry about? Well, that would be a negative 1, right? Negative 1 plus 1 is 0, and then we would just have the B. So let's do that. So we have x saying is negative 1, and then so that'd be 1 is equal to, and then we're just going to put in a negative 1 where every x is in this original equation. That's all we're doing. So negative 1 plus b, and then negative 1 minus 7. Negative 1 minus 6. Sorry about my doofusness today. Okay, so we have a negative 1 here, right? All right, so we said that already. This will cancel this, right? We'll get 0. 0 times anything is 0. So this is canceled. Then we have negative 1 minus 6. That's a negative 7, right? So we have 1 is equal to b times a negative 7. Well, we pretty much solve for b, right? So if we divide both sides by negative 7, then we get b is equal to negative 7. So we found one of our things. Now we're going to do something similar. So we found b. Now to find the other one, right, we need to kind of get rid of b. Get rid of this term here. What would we do? Well, the negative 6 we know can be canceled by a 6. So if we say x is equal to 6, then we can say 1 is equal to a times 6 plus 1. And again, I'm just plugging in 6, just like we did with the negative 1. So 6 plus 1, and then we have b times 6 minus 6. And this worked out, right? Because the 6 minus 6, just like we planned, gets canceled. And we have 1 is equal to a times 7. And again, if we did something similar, we divided both sides by 7, and we get a is equal to 1/7. This is good, right? So now we know the two missing terms. So what we're going to do at this point is we're not going to rewrite the whole expression, right? Because we said this is equal to this. We literally made that statement, okay? And we found a or b. So we're going to rewrite the integral here. We're going to go back to the integral. We're going to rewrite it. But we're going to rewrite the integral with this a and b statement because they're the same thing, right? That makes sense. But we found a and b, right? A was 1/7. So we're going to put the 1/7 on top. That's all we're going to do. And we're going to have the x minus 6, just like we had at the very top here. And then we're going to be plus, right? The b should be a negative 1/7, as I'm sure you already caught, right? So a negative 1/7. And technically there are two different integrals, but negative 1/7 over the b, which is the x plus 1, right? It's very tedious, but technically you should put a dx. I'm really lazy of it, so I won't do it all the time, but that's what you should be doing. Okay, so now we have these two statements. This looks way easier than this, doesn't it? Because now this looks like a really easy thing we've already solved before. And that's the point of partial fractions. So what we do, once you have your constant, we're going to take our constants out, actually, because we don't really need them in the integral for them to matter to the result. So then it's going to be x minus 6 dx, right, plus our negative 1/7, and we have 1 over x plus 1 dx. So we just took out the constants. And at the very last step here, this is a log integral. Now, if you're confused about how log integrals work, just remember that if we use u substitution here, u would be equal to this. The du would just be 1, so du equals dx. So even though we can use u substitution here, it really doesn't matter if this is u, or we just kind of think about it, it's always going to just be the ln of whatever it is. So like I said, there is separate videos where you can learn about how u substitution works of typical log integrals, but just know with standard simple ones like this, the integral of 1 over a linear term is just going to be ln of that linear term, okay? So basically, it's going to be negative, not negative, just 1/7, so 1/7 the ln, remember its absolute value, of x minus 6 minus 1/7 ln of x plus 1. And then you can't forget the classic plus c. So this is our answer. So this is partial fractions in a nutshell. Like I said, there are different variations of this. There's quirks. They can get a bit harder where there's more terms, and so it just takes a longer amount of time. But honestly, it is basically like this. I'm going to make another video later on about how it works with the special quirks. They take a lot longer to do, so I don't want this video to be too long, but I wanted to give you a very quick introduction to how to do a partial fraction problem. They're not crazy hard to do, but if you've never done math like this before, it can feel kind of daunting to know all these different steps that you have to go through, or else you will not get the right answer. So, thanks. Hopefully this helped.